To solve a quadratic equation, first we want to have the terms in decreasing exponent order or decreasing exponent order and set to 0. So number one is set to 0. The constant c is 0. And to solve by the factoring method, we want to always first look for the greatest common factor. The greatest common factor in this case is x. So we'll factor out x times the binomial x plus 5 is set equal to 0. So now we have a product equals 0. So if a product equals 0, generally a times b equals 0. Then to solve, we set each factor equal to 0, a equals 0 or b equals 0. In this problem, we set x equal to 0. So 0 is one of the solutions. And we set the binomial equal to 0. And solve for x equals -5, or x equals 0. Number 2 is not set equal to 0, so that's going to be the first step. Subtracting 24, having decreasing degree order, and set to 0. The greatest common factor is 1, and it is a second degree trinomial, so we try to factor it as a product of two binomials. First term x. And now we want to think of pairs of integer factors of 24, like 1 and 24, 2 and 12, 3 times 8, 4 and 6. 4 and 6 is the pair we want to use to factor 24 because the difference of 4 and 6 is -2. So to multiply with the FOIL method, we would need a minus 6x as the outer product and a plus 4 as the inner product. And positive 4 times -6 does equal -24. So we'll now set each binomial factor to 0 and solve for x. Two solutions for a second degree equation, or at most two solutions. It could be repeated roots, but at most two unique solutions. So -4 or +6. Number 3, we have decreasing degree order and set to 0. The greatest common factor is 1. And it is a second degree trinomial, so we'll try to factor it as a product of two binomials. The leading term, 2x squared, is 2x times x. And then when we factor the constant -4, we have 1 times 4. And changing the order into 4 times 1 does make a difference because of the 2x multiplying the other outer term. Well, let's try 1 and 4. And an important side note is because the greatest common factor is 1, we would not want to factor the 4 as 2 times 2 because then in the first binomial there would be a common factor of 2, which is a contradiction. All that the symbol for contradiction is a circle with an inscribed x, which means that we can't have a common factor other than 1, and this is not going to work as well when you check it. All right, so let's try 1 times 4. The outer product is 8x. The inner product is 1x. And we must be able to multiply and get plus 7x as the middle term. Therefore, we need a plus 8 and a -1. So plus with 4 makes plus 8x, and minus with 1 makes -1x, and we do get -4 as well. So set each binomial equal to 0 and solve to find the two unique solutions. 2x equals 1 or x equals -4. X is 1/2 or -4. So the two roots or solutions are real numbers. They are rational numbers. 1 to 2 is a ratio, and -4, and any integer you can write over 1, and thus is a rational number. So you have two real rational roots. Number 4, we have decreasing degree order set to 0 and the greatest factor of 1. So let's begin by factoring potentially as a product of two binomials. Let's try 4x times 2x. And then factoring 15, let's try either 3 times 5 or 5 times 3. Now, the middle coefficient -2 is kind of small, so using 3 then 5 may not work because 4 times 5 is 20, and that's not too close to -2. So let's switch the order. And let's go with this product. Now we have 4 times 3 is 12x, and 5 times 2 is 10x. The middle term is -2x. So we need a -12 and a +10, and therefore minus with 3 and plus with 5, and we do get -15 as the constant. So the multiplication checks, and we have equating each binomial to 0. And then solving, we have 4x equals -5, x equals -5/4, or 2x equals +3, x equals +3/2. So the solutions or roots are two real rational numbers. And number 5, we have decreasing exponent order. Greatest common factor is 1x to the first. We can factor out x as the first step. So what we do not want to do is put down the two blank binomials. That's a later step. We want to factor out x first. So by the distributive property, we have 6x squared, a quadratic, minus 5x minus 6. Inside the parentheses, the greatest common factor is still 1. We have a second degree trinomial, so it may factor as a product of two binomials. For 6x squared, let's try 3x times 2x. And because the greatest common factor is 1, and we don't want a contradiction, when we factor 6, we don't want to, for example, we don't want to go 3 times 2 is 6, because then you'd have a common factor of 3 and a common factor of 2. So that's not going to check, but let's switch those. Let's put 3 on the right and 2 on the left. So the outer product of the two binomials is 9x. The inner product is 4x. And the middle term on the line above is -5x. Therefore, we need a -9 and a +4. So minus on the right for minus 9x and plus 2 to make plus 4x, and we get a minus 6. So now we have three variable factors. The first is x, so we have x equals 0 is one solution for the cubic or third degree equation. We may get three unique solutions, or 3x plus 2 equals 0, or 2x minus 3 equals 0. Setting 3x plus 2 equals 0, and then subtracting 2, we have 3x equals negative 2, x equals negative 2/3. 2x equals 3, x equals 3/2. So our three solutions, if we order them, ordering is not necessary, but we have negative 2/3, 0, and 3/2. Now number 6, greatest common factor is 1. It's not a difference of two squares. It's not a trinomial, so we are going to use another method, the square root property. Square root property applies whenever we have 1x squared equals positive constant, and we need to isolate the squared term and isolate the constant. So we have 1x squared equals positive 7. Now x could be any real number, negative or positive, and we're going to take the square root of both sides of the equation. And since x could be negative, when we square root x squared, and the square root mathematically reverses or mathematically undoes the squaring, it's more than just x, because if x is negative, for example, x squared would be positive, and then we have the square root of x squared is positive, or the principal square root of x squared is positive, and the next statement says x equals, but then we'd have a positive from the square root of x squared equaling x, which could be negative. So to cover that case of x being negative, we have absolute value bars equaling the principal square root of 7. So now we have two solutions for this absolute value equation. X, the argument, is either positive or negative principal square root of 7. Number 7. We have a polynomial decreasing degree order. It's set to 0. The greatest common factor is 1. It's not a special case of the difference of two squares. So we'll have to apply the square root property. In the square root property, the squared term has to have a coefficient of positive 1. So we've isolated the squared term and we've isolated the positive constant. So now we're going to divide by 2 on both sides because we have to have a coefficient of positive 1 for the square root property. So we have 1x squared equals 3/2. We'll now take the square root of both sides. And the square root of x squared is absolute value of x equals square root of 3 divided by square root of 2. So now we have two solutions from solving the compound OR statement. X equals square root of 3 divided by square root of 2. 4, x equals negative square root of 3 divided by square root of 2. Now, final answer cannot be a fraction with a radical in its denominator. Square root of 2 cannot be simplified. 2 is a prime number, and square root of 2 is an irrational number. To rationalize the denominator, or to make the denominator a rational number, we're going to multiply by square root of 2 divided by square root of 2, which is a form of 1, so that square root of 2 times square root of 2 is square root of 4, which is the integer 2. So we have square root of 3 times 2 is 6 in the numerator, and denominator is square root of 4, which is the square root of 6 divided by the integer and rational number 2. And when you repeat that, we're going to get the negative square root of 6 divided by 2. Number 8. Solve 5x squared plus 4 equals 0. The terms are in decreasing degree order, and we have set to 0 and a greatest common factor of 1. So if we're going to use the square root property, we have to isolate the square term and isolate the constant. The constant is going to be negative. And when we divide by 5 to get a coefficient of 1, we're going to get 1x squared is equal to negative 4/5. But we know that we cannot square a real number and have the result be negative. There's no real number solution. So we can stop here and write no solution, or we can write the symbols, the empty set for no solution, or the null set, which means no solution. Number 9, solve by completing the square. The first step is the leading coefficient must be 1. It is 3, so we're going to divide through every term by 3. 3 divided by 3 is 1x squared. 12 divided by 3 is 4. And 6 divided by 3 is 2. So now we have the leading coefficient is 1. Second step is to move the constant minus 2 to the right-hand side. So we'll add, and we get equals positive 2. The next step is to add and balance the equation, add to both sides. B, which is the middle coefficient, minus 4 divided by 2. So b divided by 2 is negative 4 divided by 2, quantity squared, and do the same to both sides, quantity squared. So that makes a perfect square trinomial on the left side that is always factorable. And we'll factor first term x. And that's straightforward because the leading term is 1x squared, so it's just straightforward x times x. And minus 4 divided by 2 is minus 2. And then when you check it and FOIL multiply, you get minus 4x as the middle term. The right side is 2 plus negative 2 squared, which is 4. The left-hand side is the square of the difference, x minus 2 quantity squared equals 6. Coefficient is positive 1. So now we can apply the square root property since we have expression squared. So we'll take the square root of both sides. And so we get absolute value of x minus 2 equals principal square root of 6. An absolute value equation of this form has two solutions. Argument equals square root of 6, or argument x minus 2 equals negative square root of 6. So x equals, adding 2 to both sides, 2 plus square root of 6, or x equals 2 subtract square root of 6. And we can write that as 2 plus or minus square root of 6. Number 10, we have a second degree trinomial. We could check to see if it factors using the discriminant test or factorability. In the quadratic formula, the radicand is b squared minus 4ac. And if we plug in for b in parentheses, negative 6 squared minus 4 times a is 2 and c is negative 1. Let's see if we get a perfect square like 0, 1, 4, 9, 16, 25, 36. Well, we get 44, which is not a perfect square. So if you do not get a perfect square, we can say, therefore, we have a prime polynomial. It can't be factored. Therefore, let's go to the quadratic formula. Since we already have the discriminant, we're kind of a step ahead. The two solutions are x equals negative b, negative 6, plus or minus square root of the discriminant, which is 44, all divided by 2a, 2 times 2, which is 6 plus or minus square root of 44. We want to simplify using 4 times 11 because 4 is a perfect square that we can square root, divided by 4. So we have 6 plus or minus square root of 4 is 2, the whole number 2, and 11 stays inside, square root of 11 divided by 4. To simplify, in the numerator, we want to factor out the greatest common factor, which is 2. So 2 factored out times 3 plus or minus the square root of 11 divided by 4. So now the 2 is a factor that divides and cancels with 4 in the denominator. So we have 3 plus or minus square root of 11 divided by 2. Now, a way we can check this is using the sum of the roots method for checking. In a quadratic equation, the sum of the roots, let's call them x sub 1 plus x sub 2, must equal negative b divided by a. So the two roots added together are 3 plus square root of 11 divided by 2, and 3 minus square root of 11 divided by 2 must equal the opposite of b, where b is negative 6 divided by a, which is 2. So the fractions can be added together since they have a common denominator of 2. 3 plus 3 is 6. And the radicals square root of 11 and minus square root of 11 is 0. They cancel out, divided by 2. And the right-hand side is the same, positive 6 divided by 2. We have a true statement. So the two solutions are verified. Number 11, second degree trinomial. Greatest common factor is 1. Let's do the discriminant test for factorability to see if it's factorable or prime. The discriminant again is b squared minus 4ac. And we want to see if the discriminant is a perfect square, like 0, 1, 4, 9. Because if it is, then you can factor this trinomial. And if it isn't, we don't want to spend any time trying to factor a prime polynomial. So b is negative 4 squared minus 4 times a times c. That's 16 minus a positive product is going to be minus. We can go 4 times 3 is 12. 12 times 3 is 36. And 16 minus 36 is a negative result. And all the time, anytime you get a result that's negative, less than 0, automatically is prime, cannot be factored. So therefore, we have a prime polynomial, cannot be factored. Let's go to the quadratic formula. X equals negative b plus or minus square root of the discriminant, which is negative 20. And until we review imaginary numbers, as soon as we get square root of a negative number, we have a number that's not in the set of real numbers. We have an imaginary number, and therefore we would not continue and say the solutions are not real numbers. They are imaginary. Now let's go a little bit further with this, since we soon will be reviewing imaginary numbers. Now we're going to change negative 20 into negative 1 times positive 20 divided by negative 6. This is 4 plus or minus square root of negative 1 times square root of 20 divided by negative 6. The definition of the square root of negative 1 equals I, the imaginary unit. It's called the imaginary unit. So we have 4 plus or minus I, and then square root of 20, since 20 contains 4 as a perfect square that we can square root. That's square root of 4 times 5, all divided by negative 6. Now we have a square root of 4, which is 2, so a 2 will come outside the radical. Square root of 5 divided by negative 6. As a side note, usually I times 2 is written as 2I. 5, we're going to factor out the common factor of 2 in the numerator. So 2 times this 2 is 4 plus or minus I square root of 5, all divided by negative 6. So the 2 on the outside is a factor. We can divide and cancel a factor, but not divide and cancel a term. A term is separated by addition or subtraction. So we cannot divide and cancel the 2 that's inside the parentheses. So we have 2 plus or minus I square root of 5 divided by negative 3, which is the same as that negative on negative 3 we can write in the numerator as a negative 1, and then have a positive denominator. So negative 1 then distributed is also the same as -2 minus over plus, since the negative one distributes, but minus over plus more commonly is plus over minus, I square root of 5 divided by 3. Now, if we check by the sum of the roots method for checking, if we add the roots together, -2 plus I square root of 5 divided by 3, added to -2 minus I square root of 5 divided by 3, that should equal negative b over a. So that would be -4 divided by -3. -4 divided by -3. Now, adding the fractions, we have -2 plus -2 is -4. The two imaginary numbers are opposites. Positive I squared of 5 and minus I squared of 5 will subtract to 0 or cancel out over the common denominator of 3. And the right side is +4 divided by -3. And this statement is true. So the two solutions or the two roots are verified. And we have finished.